Hello everyone and welcome back to another episode of Node Chats. On this episode today we're going to do a deep dive into something that I want to know more about, and I'm hopeful that you're going to want to know more about, which is denial of service attacks. I was very lucky when I was looking for the guest to speak with us today that I was managed to find Thomas McDonald from the NCC Group, who actually specializes in all things denial and service attack related. Thomas, thank you for taking the time. If you wouldn't mind just giving the listeners a quick introduction about yourself and your background.
Sure thing, Neil. Yeah, so I've been working in the IT industry for just over 30 years. For most of that time at NCC, for 30 years of that time actually at NCC. I started originally as a programmer. I then moved on to doing some specialist types of testing for sort of large companies, governments, and other entities of that nature. Then I moved into security testing as a pen tester around about 2000. And then latterly in 2012, roughly, we started up our DDoS simulation testing service, which I started working on. Sorry, I'm...
That's all right. Get a glass of water if you like. Yeah, grab some.
Yeah, I'm just going to get a glass of water.
Yeah, you're fine.
Right, back again.
Yeah, carry on.
That's what happens when you bound up the stairs. So, more recently, working on our DDoS simulation services, which we started around about 2012 at NCC Group. And from there, I've been basically building out a team who provide our DDoS testing services to our customers.
Great stuff. So I think what would be good for the listeners is certainly my environment, my network as an underwriter is involved heavily in cyber insurance, and brokers that sell our products as well as other people's products. Certainly one of the areas of cover that we cover businesses against, and certainly something that we talk with our brokers and our brokers speak with their insureds about is around the topic of denial of service attack. But what I want to do in this podcast is really I want to do a bit of a deep dive, but starting from the very beginning. So just from a layman's perspective, or in a very simple term, how would you describe a denial of service attack? What is it by its nature? Can you just do a quick explanation of it?
Sure, yeah. So DDoS attacks, it stands for distributed denial of service. It sort of does what it says on the tin. It's trying to deny you access as an end user to a service that you're trying to use. The service could be like a web application, for example, if you're trying to go onto an online banking site, or if you're trying to use email, or perhaps if you're in IT, if you're trying to access a router or a switch or some sort of device, something that you typically access over the internet. The purpose of a denial of service really is to deny you access to that service by making it unavailable. The distributed part really is the fact that when attackers are trying to deny you that service, they're going to use a large number of systems sending data to the target, to the web application, for example, such that it renders it unusable by you, the end user. And in a nutshell, that's what it is. It's a family of attacks that are under what's called DOS attacks, denial of service attacks.
Yes, got it. That makes a lot of sense.
Yeah, so denial of service attacks typically are slightly different in so much as they're trying to achieve the same end, but rather than having lots and lots of systems attacking a particular target, you typically only have one system attacking a target.
Yes.
And that one system is typically using some known flaw on the system that's being attacked.
Yes, and I think we'll get into that later, but certainly what people perceive as a denial of service attack, I think, is quite a simple vector. If they understand it, they think it of being very much a kind of a point and shoot, purely trying to take somebody down with pure pushing the boundaries of their bandwidth. And I think we'll do a deeper dive into that later. That kind of goes into a little bit more, but that it is a little bit more sophisticated than that now.
Yeah.
One thing that I am interested in, when was your first exposure? You mentioned 2012 as when the group set up the
Yeah.
testing. When did you first hear about it? Sort of what year?
So I actually can't remember exactly the date, but as I say, I moved into our security testing services division, which was started just before 2000. I moved in about 2001 from another part of the business to become a penetration tester effectively. And at that time, there really wasn't much of an industry, so to speak. I mean, there were a lot of groups doing nefarious things, but it was quite Heath Robinson back then, all the attacks and the defenses that were in place.
Yeah.
And I became aware of it at some point around that time, because that's roughly when DDoS attacks first started. From, just checking back, one of the first sort of DDoS attacks occurred around about 1999, and there was another one a bit later in 2000, which was the first one that was probably most known at the time, not probably known by many, but where eBay, Amazon, and some other large entities were attacked. And I think that put DDoS on the map.
Yes.
And ever since then, it's just grown. My first sort of real interactions with it, other than as part of a pen test exercise when you're testing customers or you're advising them about what to do in the case of a DDoS attack, was when we moved sort of more fully into providing DDoS testing services and providing consultancy around DDoS, which was around about 2011, 2012.
And I think it's fair to say, like most cybersecurity resources and specialisms, as the world's turned more into digitally enabled versus non-digitally enabled, that from the banking sector, from the finance sector, where there's large amounts of critical activity and movement online, where time in the digital space is worth a lot of money, that naturally lends itself to the impact that a denial of service attack could bring about on a particular service. That as well, coupled, I think, by us all as infrastructures move more to the web, to the cloud, to software as a service, to third-party infrastructures, that no longer do people do so much under their own steam. They will use third parties for various parts of their business, and in various parts of their business, banking, type payment card taking, anything like that, can certainly bring about a huge disruption to their business. One thing, a question, as we know it in 2020, has there been much change from 2012 with regards to the types of attacks that you're seeing? So denial of service attack for me has always felt very much like unsophisticated, in my opinion, from what I understand about it. But I imagine, like any crime element to it, there has grown, instead of it just being a point and shoot at one asset or one IP, I imagine that it's changed a great deal. Can you just elaborate a little bit on what you've seen over the last sort of 8 years?
Sure, yeah, there have been significant changes. The most obvious ones are the size and the frequency of the attacks. I mean, in sort of 2020, you're now probably seeing, upwards of 10 to 20 attacks a second occurring sort of globally, 20,000 a day, millions a year are happening now. And the scale of them is increasing. So whereas back in 2012, it may have been 1 gigabit, 2 gigabits, it's not uncommon to see, 10, 20, 50 gigabits. And indeed, one of the largest attacks that we saw around about 2018, I think it was, against GitHub, which is where people store their software in an open source repository, reached 1.3 terabits per second. So that just gives you an idea of the volume, the scale of the attacks. But equally,
that as an analogy is like going from a ripple in a bath to a tsunami, isn't it? I mean, you are really talking an incredible weight or volume difference there.
Yeah. And it's as you indicated, because more and more things are connected to the internet.
Yes.
Most attacks use what we call them bots or zombie systems. They're essentially systems where an attacker has taken over that device. It could be a laptop, it could be a desktop, it could be a server. Somehow or other, they've got malware onto it, which allows them to then control what is sent from that device. And the other major thing that's happened over the last few years are IoT devices, Internet of Things devices, like web cameras, embedded systems in, various boxes you have around the house. You'd be amazed at the average house, how much stuff is talking back to the internet, phones, and they can all be recruited into what we call the botnet army, which is essentially all of the systems that an attacker has at their disposal to attack a given target. So that allows them to really ramp up the volumes of traffic. And even more than that, I think around about 2013, 2014, a new class of attack became more apparent, which we call a reflection attack or an amplification attack.
Never heard about that.
And that's essentially where an attacker is using a piece of infrastructure on the internet, like a domain name server, and using that to send spoofed IP addresses, fake IP addresses of a target, and using that piece of infrastructure, which in itself has a flaw, to amplify the attacks, to really ramp up the volume. So that was a new class of attack. What we're also seeing now, as things get more sophisticated, is people are going after the applications that are running on servers. So rather than just sending very large amounts of random, traffic to a target, which is just junk effectively, trying to overwhelm the target, attackers that are more sophisticated are trying to work out where the flaws are in the web applications that might be running on the service, and tailoring the attack just to focus on that particular part of the system that they want to bring down. For example, a banking application or a retail application or a gambling site or whatever it happens to be.
Which is clearly has gone very sophisticated then. I think we certainly hear about botnets and we hear about the Internet of Things devices being compromised, or really anything that's connected to a network being compromised and used for the power. We've seen it with cryptojacking being used, but it's interesting when people are building botnets or services or botnet armies, as you say, on where they would draw their energy or their resources from. And of course, as that gets bigger, the weight or the volume of the army or the attack gets bigger. So I imagine it gets very, very hard to prevent. One thing that I always like to think about, is can it be stopped for certainty? Is there a...
So the simple answer to that is no. And I'll explain that in a little bit more detail. So if you have a service that's online, that's visible on the internet, I'll stick with the banking app analogy. It could be anything. It could be, as I say, retail site. It could be a VPN connection, where if you think about it at the moment, everyone's working from home and they're quite often VPNing into the office. Or they're using Zoom, or like we are now, or Teams. All of these things are present on the internet, which makes them a potential target. But let's just stick with the banking application because most people use that. So you go www.bank.com. You cannot stop me as a bank from targeting my bots at that particular target. What the best you can do really is attempt to mitigate and stop the traffic from having any negative effect or harm. And that's really where the arms race is at the moment. It's between the attackers trying to become more sophisticated or simply trying to up the ante with the amount of traffic they can send, and the mitigation providers who are trying to assess, analyze, and work out if the traffic is good or bad, because obviously they don't want to stop, a customer accessing the
Yeah,
banking
why would
site.
you? Yes.
So they don't want, those would be false positives, if you would call them. So they want to maximize the amount of traffic which is bad being stopped by these mitigation technologies, while still letting through people who need to use the applications. So it is possible to stop the DDoS in the sense of you can mitigate it to the point where it has no impact, but you can't stop someone from actually trying.
Yeah, it's very, you're right. So you're not stopping it, you're merely redirecting it or managing it.
Yes, they call it scrubbing.
Yeah.
There's various different terms for it: scrubbing, washing, dropping. It depends the type of approach you've taken. And some companies use multi-layered approaches to protect themselves. They'll have appliances on their own systems. They'll have internet-based scrubbing capabilities that are provided by third parties. If you go with Amazon or on AWS or Azure, a lot of these large companies that provide what's called infrastructure as a service will also provide you with DDoS mitigation built into the platform. So it is a bit like a war, and it really is continually evolving.
Like a lot of cybercrime, when we speak to different experts on particular segments, that typically when it comes to regulatory frameworks and policing and stopping these perpetrators from doing these criminal activities, I'm guessing like most, it's very hard to track the source of a denial of service attack. Not
it is, yeah. The reason being is the distributed nature of it. So essentially, in a botnet, there's what's called a command and control environment. So if I'm the botnet master, so I'm controlling the botnet from home here, for example, I have command and control systems out on the internet, which I'm speaking to over the internet using the protocols that the botnet is using, and they're controlling the end systems which are actually going to send the traffic out, which could be your mum and dad's camera, your friend's PC, which they haven't patched in years, a router that may have a flaw that has been hijacked, and literally thousands or hundreds of thousands of these will form my botnet. You will see the traffic coming from those end systems as the victim. You will not see the traffic coming from me because I'm going through various layers.
In essence, it's like a proxy, isn't it?
It is, yeah.
A proxy on a proxy. And what's really interesting is when it comes to thinking about prevention, then that's another reason what people can do to try and avoid being part of the problem versus sort of not, is really to make sure that they're keeping their devices up to date, making sure that they're not vulnerable.
Yeah, but there is a problem for end users, to be fair. So if you have a Windows laptop, and it's a recent version of Windows, like Windows 10, for example, there's absolutely no reason why you couldn't keep that up to date. But when we're talking about Internet of Things like web cameras and stuff, they come with default passwords. A lot of people, who install these at home really don't know how to configure them. And why should they, to be fair?
Sure.
And equally, even if you're pretty savvy and you change the passwords and all the rest of it, you do things correctly, a lot of these systems become legacy very, very rapidly. And the manufacturers quite often just abandon them in terms of providing updates and fixes for them. And eventually someone discovers a flaw within the architecture of the hardware that's been used in these devices, and they get exploited. And there's very little you can do about it as an end user.
I think as well, naturally, by the nature of the way IP ranges are, like it's relatively easy as well. If you were looking for a particular device that you need the hardware compromise for, just for a simple ping command prompt, you would be able to probably find a particular make of webcam, a particular make of camera.
Yeah, you don't even have to do that. There are actually there are things running on the web constantly. there's quite a well-known one called Shodan, which scans the web looking for services that are running. And you can use that to actually know in advance, who is running a particular type of web camera on, on a particular port, if they haven't changed anything, and then just simply use that information to perform your attacks. That's not the purpose of Shodan, to be fair, but it just shows you how services that provide a useful function can be used for other less useful functions, such as DDoS attacks.
Yeah, no, that's very interesting. As a business owner, or thinking about business owners in particularly, what sort of size? Kind of a lot of our typical cyber attacks can be very scattergun, can be very random.
Yeah.
Whereas it sounds more like denial of service attacks are typically fairly focused. If you're a business owner that is a very large entity, then naturally I think what the takeaway here is that engaging with typical services such as yourselves to do walkthroughs and simulation tests to make sure that they're able to handle and mitigate the event if it should occur, which is quite common. The other thought process was, when you're a business owner that relies on third parties for certain services, is it fair that you could ask them about their approach to denial of service attacks?
Yeah, so a lot of large entities will outsource their DDoS mitigation to specialist companies that provide this type of service. They may well have other defenses within their own environments. For example, they may have web application firewalls or other types of capability that are just simply built into the systems that they have. But typically, if you're a large entity which needs to have their online presence 24/7, 365 with minimal interruption, they'll have multiple data centers. They'll be very close to their ISPs. The ISPs may be providing them with mitigation, and they may engage with other third-party providers. So they tend to have layers of protection in place to try and mitigate against attacks. For smaller companies, it's more challenging because the mitigations that you need to put in place obviously need to be commensurate with what you're trying to protect, the cost of it. And these solutions can be expensive to buy and to maintain and to run. So it's more challenging for smaller entities.
I think as well, if you're not an infrastructure partner or a alliance partner for uptime, i.e. a bank, an airline, the list goes on, and it's fair to say that the impact to your business for a denial of service attack would be far less damaging. The likelihood it might happen to a third party that you rely upon. And that's why actually we insure our clients for things that happen to a third party that affect their business. So contingent business interruption through a denial of service attack for a third party, because companies that are even very large but not quite as large as some of the operations you've mentioned still rely on third parties for a lot of their uptime. And if something were to happen to that third party, let's say Visa, for example, the payment gateway that is having millions of pounds going through it every moment, let's say that payment gateway that isn't owned by the business has a denial of service attack, then all of a sudden you're not able to take payments. There's a natural knock-on effect to that business that the business owner could do nothing about. They've done nothing wrong through no fault of their own, but you could certainly mitigate that risk via an insurance solution, which makes a lot of sense.
No, that's exactly right. Yeah, so there are some things that you just are going to be beyond your control in those types of scenarios. And most companies now rely on a myriad of third parties to provide all sorts of services. Some of them aren't electronic or online or digital like we're describing, but a lot are. They are increasingly becoming online now, as everybody becomes interconnected.
Yes.
So the risks just keep going up of interruption from these types of attack. Most of the attacks actually are generally pretty unsophisticated. They're just simply large amounts of data targeted at a particular service or system that appear to be relatively simplistic. But in a lot of cases, they have the desired effect. The reason that DDoS is so popular is it's really cheap. It's become weaponized to the point where you could get your mum or dad in, pretty quickly and just press go and run them. So the tooling around it with the people who sell botnets effectively to people who want to rent them have become very, very user-friendly and easy to use. And they're effective, which is the other component. So they're cheap, easy to use, effective.
Yeah, I think we've seen as well that they have we've seen them, or we've read about them, and it's been in the press where they're, as you say, they're cheap, they're very effective. So where disruption is your main gain, not financial gain, whether that be linked to hacktivism or environmentalism or politics or even warfare, even cross. I think there's. Yeah, definitely. It feels like very much a state infrastructure utility, possibly. Like it's a very high level infrastructure risk that.
Yes, it can be, and you're right. So you've had country level attacks like happened to Estonia. You have, as you say, disruption, and even if it doesn't have the effect of denying access to services because the mitigation is working, quite often that absorbs a lot of resources in an organization to be continuously dealing with this type of incoming threat. And it's possible, and we've seen this in some cases, whilst that's going on, other attacks are taking place, which are stealing everything out the back door, whilst all of the people are focused on trying to deal with a DDoS attack and keeping the wheels on the bus.
It's interesting. The more conversations I'm having with different professionals in different segments of internet security and cyber risk as a whole, it's very interesting because there often is that commonality of a very old tactic, albeit now digitalized. So the last podcast I did, we were talking about cyber crime. And it was to do with trying to social engineer people or trying to get people to do fraudulent acts.
Yeah.
And really, it's just like pickpocketing, but you're pickpocketing a digital wallet versus a physical pocket. And it's the same with what you just described, where you often see in films and you've read about crimes of old where they'll create a certain disruption and get caught doing something at the start, knowing that draws the attention for the larger activity to happen on behind the scenes. And so they're very old tactics that that we see. I mean, there's nothing new. The only thing that's new is the landscape has changed. That the laws or the rules of physics are completely different when you go from a non-digital environment to a new digital environment.
That's it. It's like a distraction technique. You're distracting away from resources and the capability that you have to deal with things is being distracted away to deal with a DDoS attack, whilst something more sophisticated may be going on somewhere else that you don't have the bandwidth. And I don't mean physical network bandwidth. I mean your human capacity and bandwidth to deal with too many things all at once. So that definitely is a thing that we do see.
And another thing that must put the fear of God in people is the fact that they could do it at any time. And like most crime or most disruption, it will be done at the absolute worst time for you. So COVID-19 are going on at the moment. Busy period, bad period.
We are seeing upticks in attacks at this time, more and more people are at home. They're connecting more into their corporate systems over VPNs. You know, VPN could be a target because it's an external facing service that can be attacked. But equally, you're seeing what appear to be sort of activist groups targeting certain health messages. You know, you have people who are anti-vaccine, and you know, some people think that COVID was created by Bill Gates and whatever. There's a whole load of this sort of stuff going on.
Of course, yeah.
And some people are attacking, you know, information sites which are giving out information about COVID. I mean, not fake sites. I mean, like government sites, you know, are being attacked.
Yeah.
Because certain people see them as part of the reason we have this.
And as you touched on earlier, this is probably one of the only elements of hacking that I'm aware of that is, as you say, it's so cheap, it's relatively easy to do, and it's a very much
it's pretty anonymous.
Yeah, pretty anonymous. Yeah, I didn't think about that. And it's very much press a button and go.
Yeah.
So all those factors are very easy and accessible for whoever decides they want to use this for.
Yeah, it's still a crime.
Yeah.
You know, and if you get caught, it is a crime.
Yes.
But the chances of getting caught seem to be pretty remote.
Yeah.
Especially when I mentioned earlier, like 16 of these going on a second, you know, 20-odd thousand a day, you know, millions a year. You know, are you going to spot, you know, 1 or 5 or 10 or whatever being done over here or there?
No, it's not. You know, and I think to couple with that, it's not only are you going to spot it, but who or what has got the resources to then
trace it back,
trace it past possibly borders.
Yeah.
Yeah, I mean, like you said,
very, very, very difficult.
It's still classified at an individual level. It'd still be classified as quite a low-level crime as well. It wouldn't hold the level of many other crimes. So it's
but the impact can be huge. You know, to the point where, you know, if it goes on for long enough, it could be sufficient to put you out of business.
Yeah.
You know, if you're the type of company that can't withstand being offline for significant periods of time, and you're unable to mitigate the attack, it can be truly devastating.
And I think that's when I was thinking about booking type platforms like airlines, hotel chains. But then I was also thinking about, we saw with the WannaCry, even though that was ransomware related, not denial of service, the disruption was incredible.
Yeah.
And and then you think about the power grids, the utility companies, if they're unable to operate, or, you know, then you're looking at power outages and blackouts and all sorts of.
You could actually classify ransomware as a type of denial of service. It's not this type of denial of service, but it's denying you access to your files.
Oh, completely.
So it's taking the files, encrypting them, and denying you access to them.
Yeah, and that again is another compromise that's gone from being hard to do, hard to replicate, to now becoming relatively easy. You purchase it, it comes with a document on how to use it. It's quite easy to deploy onto people's systems. It's relatively effective for what you're trying to achieve. It's very difficult. Well, I don't know. We don't know anyone that's been caught, that whenever we've been involved in a circumstance, we know it's a crime and it's reported as a crime.
Yeah.
It's certainly not one that we I mean, and that has become, like denial of service attacks, just more accessible, easier to use.
It has. It's been what we would call weaponized. So essentially, taking what was relatively complex, which required a great deal of skill, and have turned it into a service almost that you can just buy. I mean, there are black markets for buying, you know, exploits, which allow you, because you need to find a way into the systems in order to inject the ransomware onto the systems.
Yes.
And typically those are done through flaws in the services, like we've been speaking about, these external facing services, not from the same denial of service perspective, but perhaps a switch or a router is running a service and there's a 0-day flaw, and that gets exploited, and it's used to go through the systems and put the malware onto these internal systems. And then once you're in, you then propagate out across the network.
One of the things I always like to think about when we have a guest on is, where you've been since 2012. Where is it in sort of 2025? And I appreciate that's a very difficult one.
Yeah.
Where do you think denial of service attacks are going to be in 5 years' time?
So they're still going to be around because they have those key features that we mentioned: cheap, easy, effective, anonymous. So all of those things will continue to be true, I suspect, over the next 5 years. The level of attacks will just simply keep growing. As more and more Internet of Things go onto the internet, and you start to have increased levels of bandwidth available, so the volume of the traffic will continue. I think one of the big things that's likely to change, and it's already changing, is the use of machine learning and artificial intelligence. I think the bots will become more sophisticated in so much as they'll start using AI and ML techniques in order to be self-adapting. At the moment, generally speaking, the way the bots are set up, most of them just send, as I say, just junk, rubbish at very high levels at a given target to overwhelm it. You do get some people who do these more sophisticated attacks where they're going to take time because they've got a particular target in mind and they're going to focus that attack. In these more sophisticated ones, I suspect that the botnet itself will become adaptive, self-learning, using machine learning techniques.
Am I right in thinking currently, the denial of service attacks that you've seen and the ones that you're dealing with, machine learning and artificial intelligence is not there at the moment? You don't see it?
It's starting to be there. You can see people on the edges of developing this stuff for probably the last 2 or 3 years. But you're not seeing widespread use of it, but it's definitely coming, and I think over the next 5 years. And similarly, the mitigation providers, who in a lot of cases use relatively unsophisticated techniques to identify bot attacks, such as looking for unusual traffic patterns, like, why would someone send the same request 1,000 times when a normal person would only do it once?
Yes.
So they're looking for trends and patterns and signatures and so on, where these things are preset into the system, and it's simply just checking to see, is this something I've seen before? No, that doesn't look right. This is sort of exceeding a threshold, and then performing some type of operation to block it or stop it or drop it. You see machine learning being used to learn what the traffic looks like without necessarily having any preset rules. Like in an adversarial network that you might have in a machine learning environment, and that really just reinforces what I was describing earlier about the sort of war nature of it.
Yeah,
one side has one, another has the other. It's almost Darwinian in nature, where the evolution just keeps ramping up. I think the difference is obviously now, Darwin, us turning into having this conversation here, took billions of years of evolution. This is happening at lightning speed, so it's,
and as you say, it's lightning speed and probably then some. It's when you compare to Darwin from human evolution, when you do look at the amount of devices that are going to be on online in 5 years' time, the amount of power that coupled with if you could expedite the AI or the machine learning by 10x or 30x, and then
Yeah,
you will have to fight fire with fire.
you do. Simply, people will not have the wherewithal from a human perspective to deal with the levels and the complexity of the attacks when that starts to happen. And you will need really systems which can adapt in real time to whatever's coming in. Because the system that's attacking you is probably adapting in real time to what it's seeing.
So in essence, instead of it being when you spoke about the volumes of incremental, it could hypothetically be constant and constantly evolving versus calling it back and forth. It could sit there and in real time be trying multiple variables to get in versus hitting, failing.
The one thing I'm convinced about, even if that takes longer than maybe 5 years, is that DDoS isn't going anywhere as an attack.
Yeah, and I thought before we had you on, and not to talk yourself out of a job, but I definitely thought before you came on that it was the type of unsophisticated, untechnical attack that over time would fall away and it'd be replaced by something else. And it's so fascinating to get the time to speak with you, Thomas, to understand this, because
the reality is, why go to all of the trouble of doing something really, really sophisticated and time-consuming when a blunderbuss will work just as well? Just load it up with things and pull the trigger. If it has a desired effect. I'll give you an analogy. When I was doing pen testing, I used to work in what was called sort of red teaming. And we used to be charged with trying to get into customers' environments, into the data centers. And when I first started doing this, I spent huge amounts of time. It's almost like casing the target, working out who went in, trying to find schematics of the building to get in, coming up with complex sort of ruses, like perhaps contacting the customer reception, saying someone's coming in for a meeting, they're running late, pretending to be someone that I'd found on the internet who worked in the building, pretending to be them, calling from their mobile and saying, could you just send them up? What I actually discovered in the end was it was far easier just to rock up at 8 in the morning with everyone else who was going into the building and go in with them. And really what that demonstrated to me was simplest quite often is best.
Yeah.
The more complex, the more challenging, the more likely it is to go wrong, unless you're willing to invest huge amounts of time. And that's what I was saying. Some people, some organizations, some governments are willing to take the time, focus, be very careful, go for the target when they're ready to. But in most cases, you don't need to do any of that. Just simply
run with the masses, go in with volume, and you're likely to be successful.
Yeah.
Sadly.
And ultimately as well, a lot of these things, you're targeting a lot of different organizations. You only need to get lucky. If you're going after 10,000 organizations or whatever, you only need to get lucky like 1% of the time, and you've already got a bonanza.
Yeah, that's a scary statistic, isn't it?
Yeah.
Incredible. All right. Well, Thomas, thank you. That brings us up to time. Thank you so much for taking the time to speak with us today on this topic. We'd love to have you back on downstream to find out more what you're up to. And thank you again.
You're very welcome, Neil. That's great.